Over many centuries, the turbulent surface of the North Sea has been a highway, a fishing ground, and a battlefield. Fire and destruction have too often colored its bloody past, but these flames are signs of a new activity, bringing dreams of wealth far beyond the imagination of those for whom the waves were the final barrier. The geophysical research vessel Explorer steams endless miles crisscrossing the North Sea, as, by means of seismic reflection, it explores the sedimentary beds of the continental shelf. The data are recorded on tape for future analysis and are used in many different ways. From crossed surveys, a picture can be built up of the layers of rock thousands of feet below the seabed, providing vital clues to the possible whereabouts of oil and gas. This is an isometric projection, in effect a bird's eye view of a portion of the Earth's surface as it was in Jurassic times, about 140 million years ago, when dinosaurs inhabited these hills and valleys. Actually, the hills and valleys in the projection are not the shape of the original surface, nor of the present seafloor. Over 70 million years, much else has happened. Superimposed on that landscape, there have not only been immense sedimentary deposits, but internal pressures have altered the original configuration. And in parts, oil has collected in porous sandstone under strata of hard rock. Thus was formed the Beryl Field, discovered after seismic surveys by drilling from a floating rig. Modern floating rigs are extremely sophisticated, being elaborately ballasted for stability and kept in position by complicated controls, actuated by signals from a satellite which constantly maneuvers the vessel to maintain position. Once oil is located, huge platforms have to be stabilized on the seabed to exploit the discovery. The size of these ventures is immense. It may cost 20 times more to extract and transport oil to a refinery than it would from traditionally situated oil wells. And the supply of materials and the transport of manpower to and from the platform is a very expensive operation indeed. In a Norwegian fjord, man's medieval desire to reach to heaven is being matched in these massive towers, designed to rest on the seabed and to support the great platform high above the waves. Looking like the ramparts of an ancient fort, their base comprises 19 great cylinders, each 164 feet high and 60 feet in diameter. 16 of them, designed for storage, are capable of holding nearly 1 million barrels of oil. They were built in a dry dock before being floated out into the fjord. Here they were completed and sunk until only their tops showed above the surface. On 3 of the cells, cylindrical towers were built, rising over a further 300 feet from the top of the base structure. Two of the towers have shafts for future drilling operations, each tower accommodating up to 20 wells. Work began in October 1973 and proceeded night and day, so that by April 1975, not only had the towers been built, but at Arendal, a small town in South Norway, the huge deck section was ready for the long sea voyage to Stavanger. This two-storey structure, each deck over an acre in area, had been built on two converted oil tankers. Surely the biggest catamaran in history. It is 230 miles from Arendal to Stavanger, and in the wet sea fog, the tugs make 5 knots with their impressive tow. One can imagine the towmaster's relief as they slowly glide into the fjord and moor near the 3 great towers. The platform seems almost a part of the town, and the towers become an accepted landmark. The base incorporates an elaborate pumping system, which can regulate and preserve almost any stage of buoyancy, so that this colossal mass of steel and concrete is easily lowered into the deep waters of the fjord. Three steel transition pieces, having been fabricated on land, form the links between the concrete towers and the steel platform. And that having been done, the towers descend even further until the still waters of the fjord almost lap these steel crowns. They have to be low enough to allow the platform, still suspended between the 2 tankers, to pass above them. This is an expert feat, not only of navigation, but also of technical foresight. But once the platform is in position, and it fitted to within millimeters, the towers can be gently raised to meet it and be welded to the superstructure. Secure, the entire structure rises 230 feet, thus reducing the draft of the hull to enable it to be towed out of the fjord. The towmaster's tug is equipped with every conventional navigational method. But as an additional safeguard, surveyors, positioned on shore with radio telephones, constantly check the platform's position. Although the draft has been reduced as much as possible, the base is still 250 feet below the surface, and to maneuver this through the narrow fjords is a great challenge. It takes 2 days to cover the 44 miles to the open sea. The clearance below the ballast tanks allows no room for error, and at times it is only a matter of feet. Here the platform has to be turned on its own axis, but with 68,000 horsepower in the leading tugs and 17,000 in the steering tugs aft, the whole 330,000 tons of dead weight are manoeuvred with great accuracy. At last, the final marker and departure point is passed, and the tugs are repositioned for the 200-mile tow in the open sea. Now there is no stopping, for the weather forecast cannot extend beyond a few days. It is essential to arrive over the Beryl Field in calm weather, so day and night the heaviest tow in marine history at that time moves towards a place almost midway between the Shetland Islands and Norway, a target that has to be achieved within a few feet on a featureless ocean. Once in position, the tugs radiate out from buoyancy barges placed around the target area. As seawater is admitted into the storage compartments, gravity pulls the whole structure down and embeds it in the sea floor. The Beryl A Platform is in position, and the sea has been miraculously calm. It is July 1975, less than 2 years from commencement. Although the main machinery was installed during the building of the platform, there still remains a great deal of fitting out to be done. But the fine weather experienced on the tow out is unusual in the North Sea and cannot be expected to last forever. Soon come the storms, and the transfer of heavy machinery becomes difficult and then impossible. It is reassuring that the platform is built to withstand 90-foot waves and 125 knots of wind. But the weather subsides and the work progresses, and other structures appear. Looking rather like some antediluvian sea creature that has drifted into the North Sea, the flare bridge support tower appears. In fact, it is not drifted from anywhere, but has been towed from Portugal via Rotterdam. With it positioned off the platform, a complicated system of air hoses allows flotation compartments to be ballasted as required. The compressed air controls the angle of tilt until the tower is upright, with the heavy base resting on the sea bed. The support tower is ready for the flare bridge, and on an unbelievably calm morning it arrives. Taking advantage of conditions that more resemble the Mediterranean than the North Sea, work presses on to transfer it from its position off the platform. The enormous floating crane is on a converted tanker of 60,000 tons displacement. As the daylight fades, the bridge is eased into position, and the weather holds. The purpose of the structure is to burn off surplus gas at a safe distance from the platform. Most of the gas which comes up with the oil will be re-injected into the reservoir to store it for future sale, or help increase the amount of oil which can be recovered by maintaining pressure to force the oil to the surface. Meanwhile, surplus gas is flared off. Gas is also used as fuel for turbines to drive generators capable of producing enough electricity to supply a city of 250,000 people. This is used in many ways: to supply systems to cool the crude oil, to separate water from oil, to purify ballast water, to power all manner of machinery which is packed into two complicated floors. Easier to comprehend in a model, but still as baffling as a jigsaw. That it was devised and built in 3 years is hard to believe. The control room is a mass of systems checked by other systems, until it all comes down to a man at a desk. And the men, whether at a desk or on the drilling rigs, have to be looked after. As far as food is concerned, there is little doubt of the quality of the looking after. It is generous and very varied. Accommodation is modern and comfortable. Each of the two-man cabins is equipped with its own toilet and shower, and there are recreation rooms for the few off-duty hours. But these men work hard, 12 hours a day, and in their time off they're more inclined for sleep than recreation. For work goes on night and day on this man-made island in the middle of the North Sea. By this time, the drilling rigs are operating. By using 2 of the support legs, there is direct access to the ocean floor, and the intention is to drill up to 40 wells, one vertical to the oil reservoir, 10,500 feet below, others deflected in varying degrees, so that they will be up to 2 miles away from the platform. Drilling will go on day and night, 7 days a week for 2 years. A tough, hard job in tough and hard conditions. All this intense effort, the hard work of these men, the 3 years of day and night slog building the platform, the dedication of labor and capital investment means a great deal to Britain. For when these 40 holes have been drilled and the wells are all producing, Beryl A will be able to supply about 5% of Britain's total oil requirements. A useful contribution to the effort to make the United Kingdom independent of foreign fuel sources. The oil is stored in the 16 tanks on the seabed, but then has to be transferred to tankers. And this is done through the single-point mooring, the SPM. Because it would be dangerous for a tanker to approach the platform in anything but the calmest sea, the takeoff point for the oil is a 480-foot tower to which the tanker moors a mile away from the platform. As the tanker approaches the SPM, it picks up a floating line which secures it to the mooring. The pipeline can then be hauled aboard and coupled up. From it, the 80,000-ton tankers can load oil at the rate of 40,000 barrels per hour for shipment to Mobil's refinery at Corriton on North Thameside. Thus, in 1976, less than 4 years after ordering the platform, oil production began and is expected to go on for at least 30 years. It is an astonishing story of enterprise and determination, from nothing to production in 4 years. Standing in 400 feet of water, 95 miles southeast of the Shetland Islands in the middle of the North Sea, is one of the world's most sophisticated offshore production platforms. An artificial industrial island that is making a significant contribution in the fight to restore Britain's independence and economic status.